The COVID-19 pandemic showed mankind's imperfection of the medical system and the lack of ability to quick solve the problems of virus spreading. For this reason, MIT developed the Equidock neural network, which predicts the connections of two proteins. The model could speed up a drug development by a factor of 500. Antibodies, small proteins produced by the immune system, can attach to specific parts of a virus to neutralize it. One of the directions in pharmaceutics is the creation of synthetic antibodies that prevent virus penetration into the cell. To develop such antibodies, it's necessary to find the optimal way to combine the proteins. Given the millions of possible combinations of such compounds, this task is extremely difficult to accomplish. To streamline the process, MIT researchers created a machine learning model that can directly predict the complex that will form when two proteins bind together. Their technique is between 80 and 500 times faster than state-of-the-art software methods, and often predicts protein structures that are closer to actual structures that have been observed experimentally. Octavian Eugene Ganea, a postdoc in the MIT Computer Science and Artificial Intelligence Laboratory, says, "Deep learning is very good at capturing interactions between different proteins that are otherwise difficult for chemists or biologists to write experimentally." The model the researchers developed, called Equidock, focuses on the rigid body docking, which occurs when two proteins attach by rotating or translating in 3D space. But their shapes don't squeeze or bend. The researchers incorporated geometric knowledge into the model so it understands how objects can change if they are rotated or translated in 3D space. The model also has mathematical knowledge built in that ensures the proteins always attach in the same way no matter where they exist in 3D space. This is how proteins dock in the human body. Once the model was trained, the researchers compared it to 4 other software methods. Equidock is able to predict the final protein complex after only 1 to 5 seconds. All the baselines took much longer, from between 10 minutes to an hour or more. In quality measures which calculate how closely the predicted protein complex matches the actual protein complex, Equidock was often comparable with the baselines, but sometimes it underperformed them. However, the company is not going to stop improving the neural network and plans to incorporate specific atomic interactions into Equidock so that it can make more accurate predictions. According to the creators of the neural network, their method can also be used to develop small molecules similar to drugs. And studying how proteins work thanks to artificial intelligence will now make it possible to create drugs several times faster. In the future, they plan to enhance Equidock so it can make predictions for flexible protein docking. The biggest hurdle there is the lack of data for training. So MIT researchers are working to generate synthetic data they could use to improve the model. Let us know in the comments, do you want to learn more about innovations in artificial intelligence? Subscribe to our channel, and if you want to receive more helpful information, just check it out on brutonlab.com.